All right, now, senior, let's finish the remaining questions on oxidation and reducing agents and reduction and co, and let's do number 10 too. This is number 9F. We left off at number 9. So this is number 9F. Let me just keep that there so you can. Now it says that what substance is oxidized? I've already, written the charges of potassium. On the left is 0. The charge of potassium here is +1. The charge of hydrogen here is 0. The charge of hydrogen here is +1. So that means this is reduction. I've labeled that. Can you see that? This is reduction. This is what? Oxidation. So take note of that. Let me use a different pen. This is oxidation, and this is what? Reduction. So we want to pick what substance is oxidized. That's our first question. What substance is oxidized? It is potassium that is oxidized. So that's our answer for the first question. Roman number 2. What is the reducing agent? The reducing agent is the substance oxidized. So the reducing agent is potassium. Also, it says what substance is reduced. Okay, reduction took place with water. Reduction took place with hydrogen, in water. So the oxidation number because the oxidation number of hydrogen reduced from +1 to what? Because the oxidation number of hydrogen reduced from +1 to 0. It's 0 here, but it was +1 here on the left. So because the oxidation number reduced, we say this process is a reduction, or we say reduction took place here with hydrogen. So that means the substance, but that hydrogen was present in water. So we will not say hydrogen was reduced. We will say the substance reduced is what? Water. Then number 4. What is the oxidizing agent? Water. Because the oxidizing agent gets reduced and the reducing agent gets oxidized. So take note of that. In a redox reaction, the substance that gets reduced is the what? Oxidizing agent. And the substance that gets oxidized is the reducing agent. So take note of that. Let's go to question G. In question G, what do we have in question G? It says H2S. Question G says H2S plus 2FeCl3. Let me write it down. H2S plus 2FeCl3 to give, I think it's a pretty long reaction. H2S plus 2FeCl3 to give 2FeCl2 to give 2FeCl2 plus H2 plus 2HCl to give 2FeCl2 plus 2HCl plus S. I think that's what we have here, plus 2HCl plus S. Can you see this clearly now? So we want to choose what substance is, I think I should be labeling it. What substance is oxidized? That's our first question. We also want to choose what the reducing agent is. We want to determine what the reducing agent in the reaction is. We also want to determine what substance is what? Reduced. Let me take it quickly, I'll be faster now. We want to determine what substance is reduced. We want to determine what is the substance reduced and what is the oxidizing agent. So one after the other. First thing we do is to write our oxidation numbers in the reaction. Let's go ahead and write our oxidation numbers. So here, sulfur is -2. Here, sulfur is -2. But here, sulfur is 0. So is that an increase or a decrease? From -2 to 0. Is that an increase? Yes, that's an increase. So we call this what? We call this what? Oxidation. So that's an increase in oxidation number, which means an oxidation. Then let's check. The oxidation number of hydrogen is +1 here and +1 here, so we don't have any business with hydrogen. But the oxidation number of chlorine is -1 here, -1 here, so we don't have any business with chlorine. It didn't take part in the redox process that much, or we don't need to consider it that much. But if you go to iron, this is iron 2 chloride. So excuse me. So the oxidation number of iron is +3. Iron 3 chloride. So the oxidation number of iron in this compound is +3. But +2 in this compound. We call this compound iron 2 chloride. That means this is a what? A reduction. That means we can call this a reduction, because a reduction is a decrease in oxidation number. So that's a reduction. Let's now go ahead and pick what substance is oxidized. Now, oxidation took place with sulfur when its oxidation number increased from -2 to what? 0. That's an increase in oxidation number. So the substance that is oxidized is hydrogen sulfide. We will not pick the sulfur alone. We pick the whole compound as a substance oxidized. Also, the reducing agent is hydrogen sulfide. The substance oxidized is also the reducing agent. Exactly. And what substance is reduced? In the same way, FeCl3 is reduced, because FeCl3 contains the elements that undergoes reduction. So we will say FeCl3 is reduced. What substance is the oxidizing agent? It's also FeCl3. So the oxidizing agent is what? Reduced. The reducing agent is what? Oxidized. I hope you get that in a redox reaction. That's G. Let's go to H. Let's go to question H. What do we have in question H? Zn plus Cu2 plus to give, okay, Zn plus Cu2 plus to give Zn2 plus to give Zn2 plus Cu. This one is straightforward, simple. Okay, let me change my marker then. The oxidation number of zinc is 0 on the left, but +2 on the right. The oxidation number of copper is +2 on the left, but 0 on the right. So reduction took place with copper. So because this is a reduction, then oxidation took place with what? Zinc. This is an oxidation. So take note of that. Let me try and write this not to look like it's standing on zinc. Okay, then oxidation took place with zinc. This is oxidation. So what substance? Let's pick now. What substance is oxidized? The substance oxidized is zinc. What is the reducing agent? The reducing agent is the substance that gets oxidized. So the reducing agent is also zinc. What substance is reduced? what substance is reduced? The substance reduced is what? Copper. Then, what substance is the oxidizing agent? This oxidizing agent is the one that gets reduced. So the oxidizing agent is copper. Hope you are getting the trick now. I know. Question I now. Question I, E, F, G, H, I. S2 minus Cl2, S2Cl minus. S2 minus aqueous plus Cl2 gas to give S plus 2Cl minus aqueous solid. Now this is pretty straightforward also. All we need to do is put our values under each of them. Okay, I'm trying to choose a good color. This is minus 2. The oxidation number of sulfur in this ion is minus 2. That of chlorine is 0. It's a lone element, so its oxidation number is 0. The oxidation number of the oxidation number of sulfur here is 0. That of chlorine is what? Minus 1. You don't really have business with these two. Just, quantity. But we are not bothered about the quantity now. Just the charge of the atom. So that means this is an increase in oxidation number from minus 2 to 0. So this is oxidation. Are you getting that? Now with chlorine, this is a decrease in oxidation number because the oxidation number reduced from 0 to minus 1. So this is a what? Reduction. Take note of that. So what substance is oxidized? We now want to choose what substance is what? Oxidized. The substance oxidized is the sulfide ion, because it is the sulfide ion, that changes in oxidation number from minus 2 to 0. So the sulfide ion is oxidized. The substance oxidized is the sulfide ion. What substance is the reducing agent? It's also the sulfide ion. What substance is reduced? Okay, the substance reduced is the one that has its oxidation number decreasing. Can you see that? The oxidation number of chlorine decreased from what? Decreased from 0 here to minus 1 here. So that's a reduction. The substance reduced is Cl minus. Then number 4. What is the oxidizing agent? The oxidizing agent is the substance reduced. And that's what? The Cl minus 2. So that ends question 9. About determining what substance is oxidized, what substance is reduced, and so on. What's the oxidizing agent? What's the reducing agent? In a redox reaction. Question 10 says, which of the following reactions is a redox reaction? Okay. Which of the following reactions is a redox reaction? Let me just go straight and write the question. Ag. Okay, it's Ag plus Br minus to give Ag. Ag plus Br minus aqueous to give Ag Br solid. Okay. In this case, silver is plus 1, bromine has a charge of minus 1. Silver here is still plus 1, bromine is still minus 1. There's no increase in oxidation number, plus 1, plus 1. There's also no decrease, minus 1, minus 1. So this one is not a redox reaction. Not a what? Redox reaction. Not a redox reaction. Not a redox reaction. Let's go to room B. In term B, okay, water formation. H plus 2H minus aqueous to give H2O liquid. Okay, this is what? Plus 1. Hydrogen is plus 1 here. It's also plus 1 here. Oxygen is minus 2. Hydrogen is plus 1 here too. Oxygen is minus 2. There's no increase, there's no decrease. So this reaction is not a redox reaction. Next one. C. Lead nitrate sodium chloride. Lead chloride. Okay. Let's go ahead and write that. PbNO3 plus 2NaCl to give PbCl2 plus 2NaNO3. Okay, let's now write oxidation number. Lead is plus 2 here. NO3 moved together, so nothing changed. We don't have to bother ourselves about that. Sodium is plus 1, chlorine is minus 1. Lead is plus 2, chlorine is still minus 1, sodium is plus 1. Nitrate moved together. The whole nitrate ion moved together from left to right throughout the equation. So there's no change in oxidation number. Lead is plus 2 on the left, plus 2 on the right. Sodium is plus 1 here, plus 1 here. Chlorine is minus 1 here, minus 1 here. So there's no change in oxidation number. We say this reaction is not a redox reaction. Not a redox reaction. Let's go to D. In D, what do you have? Zn plus 2H plus, okay. I think this one should be redox. Zn plus 2H plus aqueous to give what? To give Zn2 plus what? H2 gas. Here, the oxidation number. Here, the oxidation number of zinc on the left is 0. That of hydrogen is plus 1. But on the right, the oxidation number of zinc is plus 2. As you can see here, this is 2. And that of hydrogen is 0. So zinc increased in oxidation number. Hydrogen also what? Decreased in oxidation number. So that's a redox reaction. You understand? This one is a what? Redox reaction. Whenever there is a change in oxidation number, we say a redox reaction has taken place. But if there's no change in oxidation number, no redox reaction has taken place. Question E. Sodium hydroxide, okay. Okay, let me write that in. NaOH plus H2SO4. to give Na2SO4 plus water. This is a neutralization reaction. Let's put the oxidation numbers. Sodium is +1 here. OH has oxygen as -2, hydrogen as +1. Here, hydrogen is +1. SO4 moved together from left to right, so we don't need to bother ourselves about the charges of its atoms. Sodium is still +1 here. Hydrogen is still +1 here. Oxygen is -2. So essentially, none of it has changed in oxidation number. +1, +1. Oxygen is -2, -2 from left to right. Hydrogen is +1, +1. So there's no change in oxidation number. This is not a redox reaction. This is not what? A redox reaction. Let's go to question F. Mg plus O2 to give 2 MgO. Okay. 2 Mg plus O2 to give 2 MgO. Definitely, this is a redox reaction because it involves addition of oxygen. Okay, no. Oxidation number of magnesium here, as it is standing alone, is 0. That of oxygen is 0. But by the time you get to the left, the oxidation number of magnesium changes to +2, and that of oxygen becomes -2. That tells you that this has increased in oxidation number, while this has what? Decreased in oxidation number. So there's an increase and there's an increase in oxidation number, and there's a decrease in oxidation number too. So this reaction is a what? A redox reaction. That's F. Question G. Let's go to question G. It says in question G, BaCl2 plus H2SO4. Okay. Let me start this here. BaCl2 plus H2SO4 to give BaSO4 plus 2HCl. Now, what does this mean? Okay, let's try and put numbers. The oxidation number of barium here is +2. That of chlorine is -1 each. Hydrogen is +1 here. SO4 moved together from left to right. So we don't need to bother about the oxidation numbers of its atoms. Barium is still +2 here. Hydrogen is still +1. Chlorine is still -1. +2, +2, no change. +1, -1, no change. Here too, -1 for chlorine, -1 for chlorine on the left, -1 for chlorine on the right. So there's no change. This is not a redox reaction. This is not a redox reaction. As there are no changes in oxidation number. Now, H now. Question H now. 2KMnO4 plus 16 KCl. 2KMnO4 plus 16 HCl plus 16 KCl to give 2 KCl plus 2 MnCl2 plus 8H2O. 2 KCl plus 2 MnCl2 plus 8H2O. I hope you get it the way I've written it. There's not enough space here. Let me just try. 8H2O. So what we do here too is the same. Potassium is +1 here. Manganese is +7. We did this in our calculation. Potassium is +1 here, chlorine is -1. Here, potassium is +1, chlorine is -1. Manganese is now +2. Hydrogen is... Okay, I think this was meant to be 16 HCl. This was meant to be 16 KCl. It's not supposed to be KCl. It's supposed to be... This is wrong. This is an error in the question. The left hand side should have KCl, not HCl. So it's meant to be 2 KMnO4 plus 16 HCl here, not KCl. Please note that correction and make it in your textbook too. Now here, what does this mean? There's a change in oxidation number because manganese went from +7 on the left. Manganese went from +7 on the left to +2 on the right. That's a decrease in oxidation number. You understand? And that's a decrease in oxidation number. So this is a redox reaction. I don't want to bother about the increase, although it's there. It's there. So that's a decrease in oxidation number. Okay, there was one other product we didn't write, 5Cl2. Let me try and slot it in now. We did not remember to write plus 5Cl2 as part of the product. So the oxidation number of chlorine is 0 here and it's -1 here. So that's an increase in oxidation number. Can you see that? Chlorine from 0 to -1. Sorry, from -1 to 0. Its oxidation number in this compound is -1 on the left, but on the right, standing alone, chlorine gas has an oxidation number of 0. So definitely this is a redox reaction without a doubt. I now. I. What's in I? Fe plus Cu2 plus. To give Fe2 plus Cu. Okay, let's put our oxidation number. Iron is 0 here, but copper is +2. Iron has a charge of +2 on the left, copper has a charge of 0. Here, the oxidation number increased from +2 to 0. And here, the oxidation number was decreased. Here, the oxidation number increased from 0 to +2, sorry. But here, the oxidation number decreased from +2 to 0. So this one is what? Reduction. While this is what? Oxidation. So this is a redox reaction. This is definitely a redox reaction. This is a redox reaction. Let's go to the last question, J. Let's go to question J. In question J, it says 2K plus H2O, 2KOH plus H2. 2K plus H2O to give 2KOH. To give 2KOH plus H2. So let's put our necessary numbers. This is 0. This is +1 hydrogen. Hydrogen is +1 in all compounds, except in metallic hydrides where it's -1. Oxygen is -2. Potassium +1. Oxygen -2. Hydrogen +1. Hydrogen 0. So you notice hydrogen decreased in oxidation number from left to right, while potassium increased in oxidation number from left to right. So you call this an oxidation. We call this an oxidation, and we call this what? What do we call this? A reduction. So this is a redox reaction. There's an oxidation and there's a reduction. So we say this is a redox reaction. All right. That's all for our basics of oxidation and reduction equations. We'll continue from there in the next video on electrochemistry.